In this episode, we're going to make data loss prevention, DLP, feel like a practical mindset instead of a mysterious product category. Beginners often assume DLP is a single tool that magically stops sensitive information from leaving an organization. But the reality is that effective DLP starts as a way of thinking about data, people, and normal work patterns. If you don't understand what data matters, how it should be handled, and what normal movement looks like, any detection system will either miss real problems or bury you in false alarms. The goal is to build DLP thinking that is intentional. You classify data in a way humans can follow, you define handling rules that match real workflows, and you design detection so it is accurate enough to act on. When you do that, DLP becomes less about policing and more about reducing preventable harm while keeping work moving. By the end, you should be able to describe how DLP works conceptually and why noise control is just as important as detection. A good place to start is understanding what DLP is actually trying to prevent, because the phrase data loss can sound like only accidental deletion. In DLP, the focus is usually on data leaving its intended boundaries in ways that create risk, such as being emailed to the wrong recipient, copied into personal storage, posted into public spaces, or downloaded in bulk by a compromised account. Sometimes the movement is accidental, sometimes it is careless, and sometimes it is malicious, but the outcome looks similar. Sensitive data ends up where it should not be. The protective goal is not to stop all sharing, because sharing is how work happens, but to stop risky sharing and to catch it early when it occurs. That means DLP is fundamentally about context, meaning who is moving the data, where it is going, what the data is, and whether that movement makes sense for the task. If you ignore context, you either block legitimate work or you let dangerous movement blend in with normal activity. Classification is the first pillar of DLP thinking because you cannot enforce handling rules on data you have not defined. Classification is simply labeling data into categories that communicate sensitivity and intended protections, such as public, internal, confidential, or restricted. The exact labels matter less than making them understandable and consistent, because people need to know which category applies without needing a lawyer or a security engineer. A beginner mistake is trying to classify everything perfectly from day one, which leads to complexity and frustration. A better approach is to start with the most important data types, like customer records, payment data, trade secrets, and credentials, and define simple categories that map to clear handling expectations. Classification should be tied to real impact, meaning the category tells you what happens if the data leaks or is altered. When classification is grounded in impact, it becomes easier to justify and easier to follow. Classification is also about choosing what signals you will use to recognize sensitive data, because DLP needs both human understanding and machine recognizers. Some data can be recognized by patterns, like credit card numbers or social security numbers, but other sensitive information is contextual, like a strategic plan or a contract draft. Many organizations rely on a combination of pattern-based detection and content labeling, where documents are tagged or stored in locations that imply sensitivity. A key beginner lesson is that classification is not just a sticker on a file. It is a decision about what must be protected and how you will identify it reliably. If classification relies entirely on humans to label everything, it will be inconsistent. If it relies entirely on pattern matching, it will miss data that does not fit neat patterns. DLP thinking accepts that classification is a blend of automation and policy, and it aims for practical coverage rather than perfect certainty. Once data is classified, the next pillar is handling rules, which are the behaviors you expect people and systems to follow. Handling rules describe what is allowed and what is not allowed for each class of data, such as where it may be stored, how it may be shared, whether it may be emailed externally, and what approvals are required for exceptions. The most important feature of good handling rules is that they match reality, because rules that ignore real workflows get bypassed. If a team must send certain files to a vendor, then a rule that forbids all external sharing will lead to creative workarounds like screenshots, personal email, or renaming files to evade detection. That is why handling rules should be written with the people doing the work in mind, including how they collaborate under time pressure. A good rule set tells people what to do instead of only what not to do, so the safe path is obvious. When rules are realistic, compliance becomes routine rather than a battle. Handling rules also need to consider where data changes form, because DLP failures often happen when data is transformed. A spreadsheet might be exported to a report, copied into a chat message, pasted into a ticket, or summarized into an email, and the original protections may not follow the data through those transformations. DLP thinking asks, what are the normal ways this team moves information during work, and where are the moments the information becomes easier to leak? Those moments include copy and paste, printing, screenshotting, attaching files, and syncing to personal devices. Some of those actions are legitimate, but they are also leak pathways, which means control should focus on the highest risk transitions rather than trying to micromanage every click. For beginners, this is a powerful insight. Data loss is often a process failure, not a storage failure. If you control only storage but ignore movement and transformation, you will miss many real leak scenarios. Now we can talk about detection, because detection is where many people believe DLP begins, but it should actually come after classification and handling rules. Detection means recognizing when data movement violates a rule or looks risky, and then generating a signal that can trigger an action, such as alerting, blocking, or requiring extra confirmation. Detection can be done on data in storage, on data in motion, and on data in use, and each context has different trade-offs. Storage detection is good for finding exposed repositories and risky shares that already exist. In-motion detection can catch risky transfers as they happen, like sending sensitive attachments externally. In-use detection can focus on endpoints, where copying sensitive text or uploading files might be observed, but it tends to be intrusive and can generate a lot of noise. A beginner-friendly takeaway is that detection must be aligned to the handling rules, otherwise you detect a lot of activity you do not care about. The most common DLP failure is collecting endless alerts without a clear definition of what success looks like. Noise is the central challenge in DLP, and noise is not just an inconvenience. It is a security failure mode. When a system produces too many false positives, people start ignoring alerts, security teams become overwhelmed, and real incidents get lost in the background. Noise can come from overly broad rules, weak classification, or detection patterns that match common benign content. For example, a pattern that flags any long number might trigger on invoices, tracking numbers, or internal IDs that are not truly sensitive. Noise also comes from legitimate business processes that move sensitive data regularly, such as customer support handling personal records, finance sending reports, or sales sharing proposals. If you alert on every one of those normal actions, you will create an environment where alerts are treated as routine and meaningless. DLP thinking treats noise reduction as a design requirement, not as an afterthought. The goal is to build signals that are rare enough to matter and precise enough to act on quickly. One of the best ways to reduce noise is to add context to detection, because context helps distinguish normal from abnormal. Context can include who the user is, what department they are in, what systems they normally use, where the data is going, and whether the destination is typical for their role. It can also include time and volume patterns, like whether the user is downloading far more than usual or sending sensitive files to a new external domain for the first time. This does not require advanced math to understand. It is the same logic you use in everyday life when you notice something is out of character. A finance employee sending financial reports internally might be normal, but sending them to a brand new external address late at night might be worth attention. Context also helps you tune rules so that high risk moves trigger stronger responses while low risk moves trigger gentle warnings or logging. The more context you can responsibly apply, the more you can focus on true risk instead of raw pattern matches. Another key to low-noise DLP is choosing the right response for the right type of signal. Not every detection should result in a hard block, because hard blocks can break business operations and encourage bypass behavior. Sometimes the best response is a user prompt that reminds them the data is sensitive and asks them to confirm the destination, because many leaks are accidental. Other times, the right response is to quarantine a transfer or require approval, especially for highly sensitive categories like restricted data. There are also cases where logging and follow-up review are enough, such as when the movement is routine, but you still want audit visibility. Beginners often assume security must always stop the action, but in DLP, the smartest control is often the one that changes behavior without disrupting necessary work. A balanced response strategy reduces friction while still reducing risk. It also keeps security credible because users see the system as helpful rather than as a constant obstacle. DLP thinking also includes understanding the human side of data handling, because many data loss events come from normal people trying to get work done. People make mistakes under stress. They forward emails too quickly, they attach the wrong file, and they misunderstand what is considered sensitive. They may also believe that if they can access something, they are allowed to share it, which is not always true. A good DLP program, therefore, includes clear education that matches the handling rules, like teaching what belongs in each classification and why certain destinations are risky. The education should be practical and concrete, not abstract fear messaging, because people follow rules better when they understand the reason behind them. It also helps to design workflows that reduce risky choices, such as providing approved collaboration spaces and secure ways to share with external partners. When the safe way is the easy way, DLP becomes reinforcement rather than punishment. That is how you prevent data loss on purpose, through design that accounts for real human behavior. A common operational mistake is focusing only on catching bad behavior while ignoring the root causes that drive that behavior. If users keep moving data into personal accounts, that might indicate the approved tools are too hard to use, too slow, or too restrictive for the task. If teams keep copying sensitive data into tickets, it might mean there is no safe way to escalate issues with enough context. If employees keep emailing attachments externally, it might mean there is no approved external sharing method for that type of collaboration. DLP alerts can be treated as feedback about process, not just evidence of wrongdoing. A mature DLP mindset asks, what pattern of alerts is telling us where our workflow is broken? When you fix the workflow, you reduce both risk and noise, because the system stops flagging the same problems repeatedly. This is another reason DLP is not just a technology effort. It is a people and process improvement effort that uses detection as a guide. Finally, DLP thinking must include measurement, because you need to know whether the program is working. Good measurement is not about counting alerts, because lots of alerts can mean poor tuning rather than high risk. Better measures include how often true incidents occur, how quickly they are detected, how quickly they are resolved, and how often the same type of leak pathway repeats. You can also measure adoption of safe handling behaviors, such as increased use of approved storage locations or reduced external sharing of restricted data. Measuring false positive rates matters too, because high false positives degrade trust and responsiveness. The key is to treat DLP as a control system that you tune over time, not a one-time deployment. As the business changes, data changes, and workflows change, your classification, rules, and detection patterns must evolve. Purposeful prevention is a continuous practice. To wrap up, building DLP thinking means starting with a clear definition of what data matters and why, then creating classification labels that humans can apply and systems can recognize. From there, you define handling rules that match real work, focusing on where data lives, how it moves, and where it transforms into leak-prone forms. Detection comes last, and it should be designed for actionability, with a constant focus on reducing noise through context, tuned patterns, and appropriate responses. The best DLP outcomes come from making safe behavior easy, teaching people how to handle sensitive data confidently, and using alerts as feedback to improve workflows rather than as constant punishment. When you combine classification, realistic handling rules, and low noise detection, you get a DLP approach that actually protects information without paralyzing the organization. That is what it means to prevent data loss on purpose, with clarity, practicality, and controls that people can live with.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.